take a look at question 1. Question 1 says, well, solve the differential equation. The differential equation. So in this differential equation, number 1, we have dy over dx. Dy over dx equals to sine of 5x. Very well. So what is our very first step? When it comes to differential equations, you have to follow some steps. Step 1 is to identify the classification. Identify the classification. So far we talked about separable and linear. Is it separable? Is it linear? Based on which one it is, you need to solve it. So step 2, apply the method. Very good. So let's take a look at this differential equation. On the left-hand side, you have dy divided by dx. On the right-hand side, you have sine of 5x. So if it's separable, it means that we can separate dx, dy's, and their expressions in x and y from each other. Do a simple algebra. Multiply by dx. So what you're going to see, you have dy equals to sine 5x dx. Is it separable? Yes. So since it's separable, it means that we need to take the integral of both sides. Take integral of both sides. Well, the integral of dy equals the integral of sine 5x dx. The integral on the left-hand side, you only get y. On the right-hand side, remember that by doing the chain rule, the inverse of chain rule or substitution, u is equal to 5x, and du is 5 dx. So replacing 5x by u, you get the integral of sine of u du over 5, and as you can see, y is equal to a fifth negative cosine of 5x plus the constant of integration. So we found an explicit solution set for this differential equation. This is our conclusion. Conclusion is that we have the solutions of the differential equation y prime equals to sine of 5x. Remember that you can always double check your work. You can take the derivative of y and replace it back into the original equation and double check your work. Well, what about question 5? Question 5 says, solve the following. Solve x dy dx equals to 4y. The same process for each differential equation. You need to follow the process, step 1, step 2. Very well. Is this separable? It's not separable. Again, let us do some simple algebra. Multiply everything by dx, and you can divide by x, you can divide by y to bring all variables related to y on one side, related to x on the other side. So just pure algebra. Multiply by dx. Then divide by x, divide by y, and what do we get? We get dy over y equals to 4 dx divided by x. So as you can see, you have a separable differential equation. So the answer is yes. It means that we have to take the integral of both sides. Very well. So let's see what do we have. We have the integral of dy over y equals to 4, the integral of dx over x. We already know the integral of, let's write this guy down here. You recall the integral of dx over x is equal to ln of absolute value of x plus constant of integration. So on the left-hand side, you end up with ln of absolute value of y. On the right-hand side, you have 4 ln of absolute value of x plus constant of integration. What we can do, we can just apply the ln properties, or we can just write it down as log absolute value of y with base e, ln of absolute value, you get log of absolute value of y with base e equals to 4 ln of absolute value of x plus constant of integration. Remember that you can rename all of these constants. You can call it C1, C1, and then if you have multiplication or plus and minus sign next to your constant, you can relabel this. For example, call it C sub 2 or K or capital C. Let's continue. Well, here you get absolute value of y equals to e to power 4 ln of absolute value of x plus c sub 1. We are just doing basic algebra. There is nothing calculus about this. Just pure algebra. When you're solving differential equations, you have to go back and forth between calculus properties, between algebra properties. So here you get absolute value of y equals to e to 4 ln of absolute value of x times e to power c1. What are you going to see? You're going to see y is equal to plus minus e to c sub 1 e to 4 ln of absolute value of x. Very well. Can we simplify this? Of course. Remember that here you get the exponent to move to absolute value of x. It means that whatever your x is outside the absolute value, it gets exponent 4. So it's going to be always positive. So here you have y equals to c sub 2, k. Instead of using plus minus, writing this constant in this form, let's just rename it. And here you get e to ln of absolute value of x to the power 4, which is e to ln of x to the 4. ln and e, they cancel out each other. You get x to the 4th back. So here you have c times x to the 4th. This is the family of solutions. Family of solutions of the differential equation xy prime equals to 4y. This is our conclusion. Very well.